So for today, recap nested loops. We did it a few, I think 2 or 3 weeks ago. So just recap that. Then talk about why 2D arrays are useful. Go into 2D array syntax. Again, if you've had practice with one-dimensional arrays, which is what we did all of last week and in the lab, the syntax should look very similar and should hopefully be pretty straightforward. And then we'll get into some live coding problems. Any questions on anything before we get started? Okay. So recap nested loops. The example, motivating example we had used when we talked about this a few weeks ago was the example of you go to the gym, you're doing, for example, the bench press exercise, and we typically talk about it in terms of sets and reps. So you would begin set 1. When you begin set 1, you do complete rep 1, rep 2, rep 3, and then you re-rack the weights and you rest before you do the next set. But notice that when we start counting the next set, we're not saying like complete rep 4, rep 5, rep 6. We kind of reset the reps every time we do a new set. Right? So when we had done this a few weeks ago, we hadn't yet learned about for loops, so we had done this with a while loop. But because this is a counting problem, we can do it with a for loop. And so for today's class, I'm going to have you all set up for loops. We'll do it in groups. Okay, so you three things are together here. If you're okay joining it with Calvin, actually, with that. Then Omar, if you want to up here.
You want us to create a code for completing 3 reps as well?
No, we'll do that on the next slide. So for now, just what goes in the for loop here, and then we'll move on to the next slide. Think about what we wanted to print out too. We wanted to start out saying begin set 1.
You want to start at 1.
Okay. But we're using, like, think about what we're using inside the for loop. Try to match that variable, but the conditions look good. Okay, so that would be for the inner one, but for the outer loop, we're trying to do it in terms of sets. Okay. Okay. Though, are we using like index in the for loop? So right now, like what variable are we using in the for loop? Yeah, so instead of like index, we can name them set, but I think the conditions look good. Okay, I think people are on the right track here. So essentially, int set equals 1, set less than or equal to 2, because we want this loop to run 2 times, increase it by 1. All right, write the code for completing 3 reps now. So this is the inner part. Yeah, so this is going to be nested because the outer for loop is just keeping track of the sets. So this inner one. Okay. All right, let's bring it back. So our variable here is rep. We're trying to print out complete rep 1, complete rep 2, complete rep 3. So what goes in our for loop?
Rep equals 1.
Yep, int rep equals 1. Then the condition, because we want to run 3 times, 1, 2, 3. And then the update. Cool. All right, any questions here? One thing you'll note compared to when we did it with the while loops, much shorter now. We just keep everything related to the loop on one line. So again, this was the code you all wrote when we wanted to complete 2 sets. We started with begin set 1, then we'll complete our 3 reps. We'll say end set 1, then begin set 2, complete 3 reps, end set 2. So literally this code that we wrote here, complete 3 reps, we're just going to copy it and replace this comment. Okay? So it looks like a lot more code, but all we did was we took this code that completes 3 reps and we put it inside of the for loop that does each set. So the first time this runs, set equals 1, we do begin set 1, and then we come in here and we say complete rep 1, complete rep 2, complete rep 3. Then we end set 1, we start the outer loop again, begin set 2, and then here we say complete rep 1, complete rep 2, complete rep 3. And then we end set 2. And then we exit the outer loop. Questions here? Okay, when we did this with while loops a couple weeks ago, we had this concept of resetting the variable, where if we didn't put rep equals to 1, do people remember this concept, like resetting the variable? Why did we not have to explicitly do something here, like before this for loop? Yeah, so we said the initialization statement only runs once for a for loop, but it's essentially every time like the for loop block runs. So we do begin set 1, and then this is the first time this whole for loop block runs. So we set this new variable int rep equals to 1. That's essentially resetting and initializing the variable, right? And then rep becomes 2, then 3. Then we exit this loop, we run the outer loop again. And so now again, because this is like a new time we're seeing this for loop, it will set int rep equal to 1 for us. So this is another benefit of for loops over while loops, is when we're doing nested for loops, it will automatically reset this variable in the inner loop. Does that make sense? Questions? Okay. Cool. So we're going to move onto a concept of 2D arrays. And to preface it, we'll start with just one-dimensional arrays. So let's say right now in my gradebook, I have grade slots for 2 projects. So first off, I released Wordle project grades yesterday. If you don't see your grading doc, come and talk to me after class. It just means that I don't have your personal email address, so I just need that in order to send it to you, because Google Docs doesn't work with the Morehouse email. If you have questions about your grade, you can also come and ask me. Generally, the TAs were pretty lenient on grading. Usually if points were docked off, it was because I went in and it was like due to late scheduling or something like that. Overall, TAs were very impressed with your overall code comprehension, code correctness. So I think you all should be very proud of yourself for taking on the hard project and completing it. Okay, so that's the first project. Second project we're going to be releasing next week. It's going to be the final project, and I think it's very interesting in that I initially said it was going to be blackjack, but we're going to change it up a little bit to be this new dice game. And in the dice game, you all are going to come up with different player strategies, and we're going to have like a huge matrix and have every student's player strategy compete against another player strategy. And we're going to see like which student can come up with the best strategy, and also if you can beat my strategy and the other TA strategies. I'm going to have all of them create player strategies, and we're going to see who can come up with the best strategies. It's not super coding intensive, it's more iterative. So you try a strategy, you see how well it works, and then you see how you can improve it. And that's what life is like in industry in the real world. Like the coding I do at Google isn't like super complicated, it's more, can you experiment? Can you like make a change, test it, see how to improve it, suggest an idea to improve it, and then code that improvement. So that's what you all are gonna do in the project. It'll be released next week during lab. But anyways, back to this. In the gradebook, there's going to be 2 project scores for a student. So how can we define an array with 2 scores?
Grades and then index 2.
Okay, but first we need the data type.
Oh.
So what data type?
Double.
Yeah, so we'll do double grades in the square brackets, 2. So the first time when we define an array, this 2 is just the size. Any other time we see square brackets, it's going to be referring to the index. But the first time when we define it, it's just the size. So if the array is going to have 2 scores, we put in the number 2 here. Can anyone see what a potential issue could be? So this keeps the grades for 1 student. Yeah, like in this class, I have 54 students, right? And I don't want to have to create 54 different arrays for every student's project grades. It would just be too much to manage if I had to create 54 different array variables. And so that's why we have the concept of 2D arrays. 2D arrays are essentially an array of arrays. Okay? So in this case, defining a 2D array, so let's say in the gradebook, we still have the 2 project scores, just like with the one-dimensional array case. But now let's say I have 3 students. And I want to define a 2D array to hold 2 scores for each student. So I'll let everyone try to make a guess. So in your groups, and if you need paper, I'll pass around some more paper. Make your best guess at how you would define this. We haven't shared the actual syntax. Here, Paul and Cleve. Love you guys here. You two here. Ooh, Alright, make your best guess. How could you define an array to hold 2 scores for each of the 3 students? You can put down multiple guesses as well. MHC guessed. That's what it came from me. Yeah. There's 2 scores, 3 students. What would your guess be?
Arrays in C++.
Data type though still needed before. Okay. I saw some guesses. I think people are kind of on the right track. So we still put the data type, double. We still put the name, scores. In this case, we have 2 brackets. The first one is the number of rows. So it can be, we could have switched the order too. It depends on how you want to create it. In my mind, it's easier to visualize it like if we had student 0, student 1, student 2 as rows, and then project 1, project 2 as columns, and then it creates a 2x3 grid. So what this is saying, the number we put in the first bracket is the number of rows. The one we put in the second column is the number of columns. Sorry, in the second bracket is the number of columns. Okay? Yeah, question?
So could this have helped with that multiplication table problem?
Yeah, so we did the multiplication problem. That would have helped if we wanted to store the results. Right now, in that problem, we just cout'd to the console immediately. If we wanted to actually store the results and then do something with it later, we would have stored it in a 2D array. Yeah. Yeah, so anything with a grid, anything with a matrix, that can all be represented in 2D arrays. A lot of games, tic-tac-toe is a 3x3 grid. If we were building the game tic-tac-toe, we would use a 2-dimensional array. Okay, so this is essentially the same slide as before, but just generalizing it. So the data type, the name, number of rows goes in the first bracket, number of columns goes in the second. Again, both of these refer to the size. Anytime we use it later, it's going to refer to the index, but this very first time when we define it, it refers to the size. I think this next slide might be the more generalized one, though. This one here kind of keeps. How many elements are going to be in the array? How can we tell how many elements will be in the array? Yeah, so whatever sizes we have in here, you can multiply them together, and that's how you'll know how big your overall 2D array is going to be, how many elements it can store. So 3 times 2 is 6. When this is defined, we're going to have 6 elements. They're all going to have random values because we haven't assigned any values to them.
So the first one's always going to be the row?
Yes.
That be going down?
The row is in this case, we have 3 rows. So I guess it kind of depends how you want to think about it.
Okay.
It's like a relative term going down. Technically, the rows are going down.
Okay, so
But
it's row 1, row 2,
yes.
row 3.
Yeah, row 1, row 2, row 3. Okay, other questions? Okay, so again, this is kind of what I drew up on the board, but if we wanted to get like the value here, this element, what would the indexes be?
For which one?
The bottom right here.
It would be 2, 1.
Yeah, so we put the row first, so it would be index 2, column 1 would give us this value here. Okay? Okay, so in your groups again, your turn to define 2D arrays. You're going to be defining 2 arrays. The first is an 8x8 chessboard, and we're going to say every element is going to have the name of the chess piece on it, or it might just be an empty value if there's no piece on it. And then the second one is over a 5-year period, how much rainfall is there per month? And there's 12 months in a year, so that can help decide how many columns there will be. Cool, so I'll give groups a couple minutes to work on that. Remember to include the data type and the name.
We don't know what matter. I guess could be string pieces.
Really, the actual column, like string or but that's like rows.
Like I keep doing.
That's what I'm saying.
Everyone, like, if you want, it looks like
What exactly?
that's what I love.
The pseudoterminus?
For the Wheel of Fortune code, I literally, if I comment out my last line, it works. But everything else, it's like the column is up and down, rows is side.
Well, that means the variable might not be getting calculated properly if it's not printing or anything.
But like I declare it outside
And then,
of
I guess
this
it
or
goes,
whatever, and it doesn't work. But if I, like it gives back to
We can take a look.
it was 3 rows, 2 columns.
Okay.
That's 3 rows, 2 columns. That's the same as yeah, that's what I'm saying.
So I think that this is how you would go about just.
All right, can I just see what people have?
That's rows.
Rainfall will be like a number. So think about rainfall is going to be like a number. So rainfall might be like 5.3 inches of rainfall.
One would be string 2.
It's just how we just.
2 would be double.
If you wanted to be.
2 would be a double. Because
Right now you're saying the years would be the rows?
And then this 12 is the month.
It's like the columns, yeah, 12 months of the columns. Yeah, I would just like put a comment in your code saying how you like that, but it's personal preference. Okay, I think people are on the right track. 8x8 chessboard, what will this look like?
String, chess piece, 8.
Yeah, so you can choose whatever name you want, but the important parts are string is the data type. You can choose whatever name you want. I just said board, and then it's an 8x8 grid. So in this case, because both numbers are the same, it doesn't really matter. Like 8x8, it will be the same either way. And then 5-year period, the rainfall per month. You could have switched the 5 and the 12. That's what Sandra and I were just talking about. The key parts though is that you have double as a data type, and then you have 5 and you have 12. The order could have been switched. The way I'd set this up is the 5 years are going to be the rows, the 12 months are going to be the columns. But it could have been swapped if you wanted. Questions here? Okay. Okay, so now to actually initialize a 2D array, looks very similar to initializing a one-dimensional array. The difference, okay, so if we were to think about like double scores of 3, if this was just a 1D array, we still would have had like these 2 commas and we would have had 3 values. The difference now is instead of these values just being a double, it's like another array. So how we would initialize an array, that's like what goes in the 0th element here. And then another array goes here, and then another array goes here. So a 2D array is essentially an array of arrays. Okay? Yeah,
So
question.
for the first pairing, the squiggly braces.
Yeah.
Is that 90, 84 in the first row?
Yeah. So each of these arrays represent a row.
Okay.
And because we have 3 rows, we have like row 0, row 1, row 2. So this is going to get filled in as like 90 and 84 goes in row 0, 98, 88 is row 1, 62 and 100 is row 2. And if we're thinking about it not in terms of numbers, but just in terms of like students, you could think of each of these, like this 90 and 84 are the project grades for the 0th student. 98 and 88 are the project grades for the first student. 62 and 100 are the project grades for the second student. Yeah? Okay. I think it looks a little bit overwhelming to see it up on the board. Again, the best way to practice is to actually do it and code it. So today's lab 10 is going to be working with 2D arrays. And so that's where you'll actually be able to put this into practice, make sure that you truly understand it. Okay, questions here on initializing a 2D array? I'm hoping people have strong fundamentals on initializing the 1D array from lab. I think if you jump immediately to 2D arrays, it's going to be too overwhelming. So if you haven't done lab 9 yet, make sure you go back and do lab 9 before you start lab 10. Yep. Okay, so now if we want to modify a 2D array, very similar to modifying a 1D array, scores 2 of 0. Which element here is going to change to 75?
62.
Yeah, so we go to row 2, column 0, which is 62, and that's going to change to a 75. This scores 2 of 0 acts just like a variable. We could have put it on the right side and added something to it. We can do like the plus equals operator. Anything we can do with a variable, we can do with this syntax here. Because each of these boxes essentially represent like one variable. Okay, I think that's all my slides for 2D arrays before we get into the coding. Any questions? Make sense? Yep. Okay. So I'm going to have you all in groups again, write out this code, and then we'll put it in the code visualizer after. We have those 6 values. We have it in that grid. Now we want to print out every element in the array. So again, the way we got an element was using like this syntax with the double brackets. So you know that's probably what you're going to have to do something similar in here. But we want to use variables in those brackets. So what goes in the outer for loop, what goes in the inner for loop, and then what can we print out? It might be helpful to use like the variable names row and col, C-O-L, which is short for column, when you're setting up your for loops. So if it's like 5 minutes before it's on this way.
I think I should start with row 2 or column. No, index, so you can subtract 1. And then it'll be for int column equals 0. Column is less than or minus 1. Less than or equal to 1. Column plus column equals column plus 1. C out.
Or,
What am I
you
seeing?
can use index or row, whatever. For index, equals
C out,
1.
row, index, column.
Then it would be index less than equal to 3.
Yes, but let's shift everything over because with arrays, we'll start at 0.
Oh, yeah.
Because first element is 0. So 0 and then less than or equal to 2. Yep.
And then, plus 4.
Yep.
One.
Yeah. So that'd be your outer loop. That'll help us get each row. And then the inner loop, we need to get every column.
Okay, and then, call equals 0. It'll be basically the same thing as the first one, and call equals 0.
Variables
It'll be less than equals 1.
Yeah, like some we use like the index, then we can't use the index.
And, column
That's what I think.
That's what I got.
It's just hard just to organize.
Yeah.
You know, at the end, what I do is I just go back and edit
Scores.
It's a mess.
Scores index and then
And then in your like, we know if the outer loop row is starting at 0, and the inner loop column starts at 0, then becomes 1. We can, how do I describe it?
Cause like, I'm just trying to, for the condition, so like, would it be one that's less than the third index? Or?
Yeah, so at least for like, if for the row one, because we know there's only 3 rows total,
Yeah.
we would need row to start at 0 and be less than 3. That way the row value will be 0, 1, and 2.
Okay. And that, wouldn't that be the same for the second one?
It would be close, but the second one is a little bit smaller, like there's only 2 columns.
So then obviously when you run it, rows would be at 0, columns would be at 0. And then you keep doing it. Exactly.
Chilling, bro.
That's the way you do it up there.
So what we were saying is, so we were gonna maintain the index type stuff.
Yeah, we can. Yeah.
And then you will see out, well,
Okay. I think people are on the right track. Alright. Yeah.
So if that's the case, is index really necessary? Or if we as long as we initialize a variable to a number, can't we leave that variable?
Yeah, index is typically used with 1D arrays because it's very clear. If you ever looked at anyone's code and you saw index, you would know they're either going through a string or going through an I. So it's just like a good code style. But yeah, technically you could have named it whatever you want. And sometimes people just do like int I for short. I personally still like using index because it makes the code clear. In this case, because we can't do index here and here, I like row and col for your 2D arrays. That's like kind of the standard for 2D arrays. Yeah. Okay. So outer for loop. We want to go over every row in this 2D array. So how can we set up the outer for loop? Okay. And then what's the condition? Yeah, row less than or equal to 2, or we typically just make it less than the length. So we can say like row less than 3. And then row plus equals 1. So kind of like in the sets and reps problem, this is going to be our outer one to just, in the outer loop, go through it 3 times. What can go in the inner loop?
For int call.
Okay, int call equals 0. What's the condition?
Call less than 2.
Yep, call plus equals 1. Okay, and now for the crux of the problem, what can we see out if we want to get every element?
Scores, bracket row, bracket call.
Yeah. So we're going to put this in the visualizer so we can actually see what's going to go on. But do people have any questions before we do that? Okay, let's put it in and see what it looks like. I'm not sure if the oh nice, the visualizer can do 2D arrays. That's sweet. Okay. Cool. So we initialize it with these 3 rows. So 90 and 84 is the first row, 98 and 88 is the second row, 62 and 100 is the third row. We have, what's the value of row going to be equal to after line 8 runs?
0.
Yep, because we're setting int row equal to 0. What's the value of call going to be?
0.
0 as well. And so when we see out 0 and 0, what value is going to be printed out? 90. So we're row 0, column 0. So 90 is going to be printed out that we have here. Also, let me make this end L so that they each come out on new lines. Okay, so we said the first one's 90. Then we repeat the inner loop because call is now equal to 1 because we did plus equals 1. 1 is less than 2. So now we print out scores of 0, 1. What is that going to be? 84. So we're in row 0, column 1. So what this inner loop is doing is for a given row, print out every column value in that row. So we were working just purely with row 0, and the first time we did row 0, column 0, then we did row 0, column 1. Now column is 2. Is that less than 2? No. So we exit the inner loop, and now we go up to the outer loop. And what happens to row? Yeah, so we've completely finished the 0th row. So now we want to process row 1. Okay? And then here, column, initially it was 2, but what's going to happen at line 9? Yeah, so this for loop is automatically going to do the reset for us. If we were doing this with while loops, we would have had to, before this loop, say call is equal to 0. But because this line is going to run now, it's automatically going to do the reset for us. So column is 0, and what's going to be printed out now? Row 1, column 0. 98. So notice in this iteration of the inner loop, we're processing row 1. So now column goes up 1, and what do we print out? Row 1, column 1? 88. Right? And now column is 2. That's not less than 2. Technically, we'd be here if we tried to process this, and we would get what we call an index out of bounds exception. But fortunately, we set up our for loop correctly, so we can exit this inner loop. And what happens to row in the outer loop? Yeah, row goes up to 2. So now we're going to process this last row. Okay? And for this last row, the call gets reset to 0. So row 2, column 0, what is that? 62. And then row 2, column 1, 100. Now call 2, it's 2 less than 2. Nope. So we come here, row is going to get increased to 3. Is 3 less than 3? No. So we exit the outer loop as well. And then if we had more code, that would run. But in this case, we just exit the program. All right. Any questions on this visualization? Again, it's a little bit tough. With arrays, it's hard to always have to do the visualization to really think about exactly what the syntax will be. That's why I was really trying to drill down with 1D arrays. The for loop almost always looks the same. If we're trying to get every element in the array, we usually start the index at 0, go less than the length, increase index by 1 each time. So that's just like through repetition, you should kind of get that memorized. 2D arrays are very similar. If we want to get every element in the array, we need our outer loop to go over every row, and we need our inner loop to go over every column. And then to get the element, we just put the name of the array, and then the row and the call index. Yeah? In this problem, we were just printing out. In the lab, we talk about like doing the sum of the numbers. What would change in here if we wanted to sum all the elements instead of just printing it out?
Instead of the CO, would you just put it all into sum, say add to the total? Or?
Yeah, so we would, instead of C out here, so we could get rid of like this end L, we would need a sum variable. So up here, we can create like double sum. Is that right? Is there anything else we have to do there? Yeah, so a lot of people forget to set it to 0, especially with like the num mistakes, money total in the Wheel of Fortune homework. We need to set it to 0 initially so that there's some value. And then what can we do here? Yeah. Could we just do this? I've seen a lot of people do this, like sum is equal to the scores. What's wrong with this?
It'll just assign the array to sum.
Yeah, it'll just assign whatever element to sum. So this sum is just going to be like the last element that we process. So what can we do instead? Yeah, we can do plus equals. Plus equals is also the same as saying we call this like an accumulator. So it's a running sum. Every time we're adding a value to sum, every time that the loop runs. So we want to take whatever work we've already done and just add the next element to it. So you can either do sum equals sum plus scores, or you can do plus equals to just add on to sum. Both of those statements do the same thing. Cool. All right, any questions there? Boom, boom, boom. Okay, we did code visualizer, print every element in the 2D array. Okay, today at 6 p.m., if people are interested, the Tech N Club is putting on like a UX design workshop. So especially if you think you're like kind of interested in CS, but you're more interested in the design aspect, it could be interesting to check it out. It'll be after lab today, and I think in the same room, 233. So if you come into lab from 5 to 6, you can just stay, and I think they'll have some food as well. And then what's due? I want this week to be the catch-up week, because next week we start the final project. So if there's a time to catch up on assignments, it's this week. Add an incentive of you have the option or the ability to win some cash this Friday. You just have to finish these 4 assignments. In my mind, Lab 7 and Lab 9, if you attended lab, I think most students finished it during the lab time. Come in today. Come in today from 3 to 5 if you haven't finished any of these 4 assignments. You can even come in from 5 to 6 and still work on one of these previous assignments. If you finished all the assignments, you can still come into lab today as we're going to be working on Lab 10, which is going to be working with 2D arrays. Yep. We're probably going to do this at the beginning of class. So, if you finished everything, make sure you come on time to the beginning of class. We'll probably try to finish it off in like the first 5 to 10 minutes. So to be eligible, like I need to put you in the random draw. Make sure you come to class on time, right? Any questions here?
By when do they have to be completed?
By the time you come into class on Friday. Essentially, like whichever students are on time at the beginning of class, I'll put their names in like a random draw. We'll choose 3 names, and then I will go and check those 3 names to make sure that they've finished these 4 assignments. And if someone hasn't, then we'll choose an alternate to fill their spot. Yep. So get them in by Friday before class. That's also when I'm going to start putting them into the grade book. So I've been a little bit lenient so far. I'm going to input grades this Friday after class, so really try to get these assignments in. Office hours, or I'm rebranding it as like working party. We're just going to have like a bunch of people in this like conference room working on these assignments. I'll have my TAs in there as well. They can come and help if need be. View it as like a working session. You don't have to have questions when you come in, but you can work, and then if you have a question, you can let me know. Then lab from 5 to 6. One other announcement I had, elections next week. I think this is the first time a lot of you will be able to vote, right? 18 years or older. Voting's important. Like, I would take it seriously. Do they have like voting registration stuff on campus or places to vote on campus?
They have registration stuff.
Okay, registration stuff. Where's like the nearest voting booth? Do they have one on campus?
They have some type of vans, right?
Yeah.
Going on.
Okay. Yeah, so if there's a van that comes on campus, when's election day? Is it November 4th?
November 8th.
November 8th? All right, that's a Tuesday?
Yeah, the 4th is the last day for early voting.
Okay, cool. So November 8th, put it on your radar. It's going to be a close election, especially here in Georgia. I don't care who you vote for. I have my own preferences, but I won't share it. But the important thing is that your voice is heard, right? Especially in Georgia where it's super close. Every vote will count. Sweet. Thanks, everyone.